Hello everyone, this video I'm going to solve a problem about limiting reactant. Let's get started. Boron can be prepared by reacting B2O3 with magnesium at high temperatures, and we have the equation. What mass of boron is obtained if 0.75 grams B2O3 are reacted with 0.5 grams of magnesium? As we agreed before, we have to write the equation as a first step to answer or to solve our problem. Here's the equation, which is showing the mole ratio. Then we will write what we have. We have 0.75 grams of B2O3 and we have 0.5 grams magnesium. And we are trying to find the mass of boron. Okay, so as a first step, we are writing the equation to check the mole ratio and to write down what we have as givens. As we can see here, we have information, we have givens about both reactants. What does it mean? It means that we need to check which one is limiting reactants, because we cannot calculate the product based on any of them. We cannot just choose any one of the reactants. We need first to check which one is limiting reactant before using any one of them to calculate the boron produced. So we have here 0.75 B2O3 and 0.5 grams magnesium. What we're gonna do as a second step is we need to convert those grams into moles. How we can do that? By multiplying or by dividing it over the molar mass. So the number of moles of B2O3 is equal to the mass over the molar mass of B2O3, which will be 0.01 mole. Then on the other side, or for magnesium, we need to find the number of moles of magnesium, which is the mass over molar mass, 0.02 moles. Okay, so now it's time to check which one is limiting reactants. Why we can do that? Because we have the mole ratio. The mole ratio in this problem, we have 1 mole here, we have 3 moles here, so the ratio is 1 to 3. And we have now those givens. So we need to check which one is limiting. From the reaction equation, we can see that the mole ratio between B2O3 and magnesium is 1 to 3. So we have, if we have, let's check from this side first. If we have, or if we will use this reactant 0.02 mole magnesium, the equivalent amount or the equivalent moles of B2O3 is 0.0066. If we used magnesium, if we used the given about magnesium, we should need 0.0066 moles of B2O3. But what we have in the problem is more than that. We have 0.01 mole, which means that B2O3 is more than what we should have. So B2O3 is excess reactant. What we have as given, 0.01 B2O3 is more than what we should have. So B2O3 is excess reactant. Okay, if I would like to make sure that I'm following the correct steps, and B2O3 is excess and Mg is limiting, we can do it from the other side. So again, from the reaction equation, the mole ratio between B2O3 and Mg is 1 to 3. So if we have 0.01, now I will calculate it. I will calculate the amount of magnesium, that I would need if I used 0.01 B2O3. The equivalent number of moles of Mg is 0.03. So if I used these givens of moles of B2O3, I should have 0.03 magnesium, while what I have is less than what I need, which means that Mg is the limiting reactant. So now I have to be sure that Mg is limiting reactant, B2O3 is excess reactant. And based on that, I should not consider B2O3 in my calculations, otherwise it will give me wrong answer. And I have to use Mg because this is the limiting reactant. Okay, let's go check how many grams we could have from boron if we use the Mg. From the reaction equation again, we can see the mole ratio between magnesium, which is the limiting reactant, and boron, which is the unknown. It is 3 to 2. Now we would like to convert this number of moles into masses because we would like to find the mass. So it will be the mass of magnesium will be the number of moles N by molar mass. So it's 72.93. And also the mass of boron is 21.62 grams. What if we have 0.5 grams, which is given in the problem? Here is it, 0.5 grams of magnesium. We'll just cross multiply. So the equivalent mass of boron after cross multiplying, we will cross multiply. So it will become 0.5 multiplied by 21.62 all over 72.93. The answer is 0.148 grams of boron. And that's it.